Okay, this we'll start the second part. Let's just go back and review just briefly. What we're doing here is two variable statistics. We call it correlation and linear regression. There's three parts: correlation, regression, and residuals. The part that we're concentrating on right now is correlation. The three aspects, or at least three parts of correlation. The first thing is to examine a picture, and we call that a scatter plot in this situation. The previous video that I put up did that. So the purpose of this video is to examine the numerical summaries, what we call the correlation coefficient and the coefficient of determination. What I intend to do here is to show you on your calculator how to find these, and how we make interpretations from those. So let's get it started. The first thing I want you to understand is when we have our data on our calculator is we can construct these numbers using our calculator. So let's see, to do that on the calculator, what we would do is we would go to Stat, and we would go over to Test. And there are other ways that you can do this. Keep that in mind. But I like this one best because it does a couple things. First of all, it sets you up if you would ever take my Math 2500 class. So it sets you up for that. It also gives you, pretty much everything you need in one-stop shop. So, again, mine is located at F. Yours is going to be somewhere close to that. So it's called, Lin Reg T-Test. Okay. So hit Enter. Now, just one more place that it kind of, we have to make sure that we know which variable is our X and which is our Y. So I put my X's, which are the horsepower, in L1. I put my Y's, which is the miles per gallon, in L2. Now, this is an important step here. If we come on down to frequency, that should be 1. This beta and rho stuff, we don't worry about that kind of information in this class. But what I need you to do is I need you to come down to REGEQ. Now, this is an important part. I'm going to show you how to do this one time. And if you do it correctly, then you're not going to have to worry about this again. Also, it's going to be a kind of a barometer on whether or not you watch the video. Because if you start pulling out your calculator in class and you don't have this, I'm going to be suspect of whether you watch the video, which is bad, right? I gave you today off because of the extreme cold weather, so surely you can grab a cup of coffee and belly up to the computer and watch this, okay? So for some reason my daughter decided she wanted to come over and mess with me while I'm putting up the video, so.
Really?
Okay. Now, what I need you to do here, and again, the icon needs to be flashing at REGEQ. If you go to VARS, where I'm circling right here, and go over at the top to YVARS, and what I need is function, so that's the default, so hit Enter. Now what you're going to see there is you're going to see Y1, okay? So I need to hit Enter again, so it's going to kind of copy and paste it into REGEQ, which is exactly what I want, okay? Now, come on down to Calculate. Guys, when we're doing problems, in other words, when your grade's at stake, when the stakes go up, I think it's a good idea to just stop, make sure that we've got L1 and L2 set, which we do. Make sure we've got frequency of 1. This line right here, it doesn't matter what we have that set at. We don't use that. We're not conducting any inference. And the REGEQ, we need to have Y1. Okay, if everything's set up, hit Calculate, so come back over and hit Enter. And we get a lot of stuff. Now, what we're most interested in at this stage is all the way to the bottom. And all the way at the bottom, if you see, we get an R value of negative 0.68. I'm going to write this down. So our R value is negative 0.68. Guys, these things are descriptive statistics measures, so you're going to report the R to two places. The R square is reported as a percentage. So we end up with 45.96%, and we would report that as 46.0%. Okay, so this to convert a decimal to a percentage, we move the decimal over two places. This 9 is impacted by the 6, and this 5 is impacted by the 9. So it's one of the more difficult ones to round, but nevertheless, our answer would be 46.0%. So if I go back to let me. Okay. Let me go back to the document. So what we have here, our R value equals negative 0.68, and our R squared equals 46.0%. Again, gang, it's important that we trying to do something on the other screen that's not working for some reason. Okay. Alright, even technology awesome when it works. There we go. Alright, that was smooth. Not. Okay, guys, let's go back to the interpretations of these. This is going to be a short video, actually. So the interpretations are this. The reason I wanted the reason I wanted the R or the 68. Okay. The reason I wanted my iPad paired is I wanted to show you the way that we typically interpret this. So, guys, the interpretation of R, and that's what I want to do over here. A couple of facts about R. First of all, R will always be between -1 and +1. So if someone tells you they conducted a two-variable statistics and they get an R value of +1.28, well, guys, this would be impossible. Because our R values have to be between -1 and +1. A really good way of looking at what this R value tells us is to look at the segment between -1 and +1. And guys, this is not perfect, but this gives you a pretty good indication of what goes on in the interpretation. So let's take a look at the segment between -1 and +1, which again, those are the only values that R can attain. Let's break this up from negative 0.2 to negative 0.8 to positive 0.2 and over here positive 0.8. Alright, guys, if we get an R value in here for this class, we're going to call that obviously a positive relationship, but we're going to also refer to that as a strong relationship. If we get an R value in this, we're going to call this a negative strong.
Bailey, take the trash.
So at the end of the day, the strength of the relationship is indicated by how close it is to either positive 1 or negative 1. So if we have an R value close to negative 1, we're talking about a negative strong relationship. An R value close to positive 1, it's a positive strong relationship. Guys, when we get an R value in this area from negative 0.2 to negative 0.8, it's still going to be negative. But we're going to refer to this as a negative moderate. This segment right here, from positive 0.2 to positive 0.8, we're going to refer to this as a positive moderate. Guys, anything from negative 0.2 to positive 0.2, these are weak relationships. Obviously, this would be a weak negative, and this would be a weak positive. Hey, Bailey, would you let Darby in, please? So, let's see what our R value. Guys, our R value was negative 0.68, so we would conclude there is a negative and moderate relationship between horsepower and miles per gallon. Guys, it's that easy. First of all, we looked at our scatter plot. Sometimes scatter plots, sometimes the visual. Remember back here we did a scatter plot and we came up with the determination that the relationship was linear, negative, and moderate. Sometimes the visual can be misleading. In fact, I'll have an example of that for you here in about 2 weeks. But the R value gives us a much better indication of the direction. Guys, clearly negative because the R value is negative. And moderate because the 0.68, the negative 0.68, fell in that particular segment of the line that I gave you. Guys, that needs to go in your notes. You're not going to have access to these videos when you're in class working on things. So, treat these videos just exactly like you would in class. Get this information in your notes. You're not going to remember it. The mind just doesn't work that way, or at least most people's don't. Guys, the next thing I want to turn out, or to indicate to you, is R squared. And R squared is a little bit more, I hate that autocorrect. R squared is a, well, apparently that's what it's going to force me to do. Let's go in just. All right, R squared, and guys, in this case, R squared was equal to, what, 46.0%. All right? Now, the interpretation here, this is a little tougher. We would say that 46.0% of the variance in our Y, which in this case is miles per gallon, is explained by small changes in X, which is, of course, our horsepower. The things that will change in this from problem to problem will be the number and the variable. So the next, the assignment that we do in class will probably examine, two different variables. It may be, for example, weight and speed. When you go to interpret R squared in your future examples and your future problems, the things that I've underlined here will be the only things that will change. Same thing up here in R. I'm going to underline negative, and I'm going to underline moderate, and I'm going to underline the variable, horsepower, and Next, I'm going to underline miles per gallon. So guys, when I ask you to interpret a correlation coefficient for our next variable, for our next data set, you're going to tell me there is. You'll insert either positive or negative, whichever it is. You'll insert either strong, weak, or moderate for the relationship. And obviously you're going to put the appropriate variables at the end of the interpretation. Same thing for the R-squared. The R-squared, you're going to put the value that we get from our calculator, and you're going to tell me that 46, well, whatever the percentage is of the variance in our Y. Whatever variable that is our Y in that data set is explained by small changes in X. Okay? Now, what I'll do, this is by far one of the toughest interpretations that we have. You know, what I'll do when we get in class is we'll dive into a lot more detail about the interpretation of R-squared. So guys, what have we done? Well, in summary, we've completed the first part. We've completed the first part. We've completed the first part, correlation. Our conclusions. There appears to be a linear, moderate, and negative relationship between horsepower and miles per gallon. Guys, that's it. This is going to be a short one. So enjoy. The next video will be on the second part, which is the regression. It's a little tougher, but not much. It's still about the same. All right. Take care.